So, making 3D easy. What do I mean by that? Well, actually, it's about making 3D pervasive. And pervasive means how easy it is to move something in 3D from one computer to another computer, to a phone, to another device. Right now, it's actually pretty difficult to do that. And 3D exists in many different sort of nascent technologies. But in order to sort of set the scene, I'm going to take you back 20 or so years to 1996. Back in 1996, this is what video games look like. And this is kind of where 3D and computing first really started to sort of hit the mainstream. We've got Quake, Crash Bandicoot, Duke Nukem 3D, Super Mario. My particular favorite was Wipeout. I was about the right age, I guess. And what you have to remember is before this, before like, these kind of consoles and PC games came around, it was all about SNES and Sega Mega Drive. These were all 2D games. But 3D had a sort of real transformative effect on the console and gaming industry. This is what the computer world looked like. People sat at desks with these kind of crazy big machines and big sort of displays that fired lasers at your eyes. And everyone was talking about the fall of Apple. They were in real trouble. And funnily enough, VR was the future in 1996. But really, the point of this is, in 1996, the internet sucked. We're talking 56K modems. We're talking pictures arriving line by line by line. To give you some sense of context, if you wanted to watch the latest episode of Breaking Bad, well, firstly, there were no sort of services to do it. You'd have to sort of download it illegally from somewhere. But it would take you around 30 to 40 hours to download it. Well, what about websites? They were great. This is kind of what website design looked like in 1996. It's not the sort of super HTML5, wonderful top-to-bottom scrolling things that you see on sort of hipster websites these days. It was kind of like this. So now try and imagine a company like Instagram. If I said to you in 1996, there's going to be a company called Instagram, and it's going to be worth $1 billion, 15, 16, 17 years' time, you'd have an incredibly difficult time making all the necessary mental leaps. And that's because tons of stuff has to change in order for Instagram to be valued and bought at that price. Really, companies have to be valued not about profit and loss, they have to be valued at scale of audience. And really, the investment to create something like Instagram has to be pretty small, has to be pretty easy. You have to enable kind of startups to do these things. So, what are the technologies that have happened that enabled Instagram to succeed? Well, firstly, there's the digital camera revolution. Back in 1996, you were taking pictures, it was on film. You had to go and get it developed. Digital cameras allow things to be disposable. Super fast internet. I'm not just talking about fiber optics across the ocean. I'm talking also about 4G. 5G is coming. Pay-as-you-go service, or the cloud as it's called these days. When I used to work at Sony, and when we were building SingStar Online, we had to go and buy a box. It's honestly like something from Silicon Valley, if people watch that show. We had to go buy a box. It was a black box. It would get hosted in a room, and Kevin, the engineer, would go and look after it. And it cost hundreds of thousands of pounds. Nowadays, you can basically write web services for free. And lastly, you've got a supercomputer in your pockets. It natively understands through hardware and software, image codecs, video codecs, and all sorts of other multimedia. All of these things can happen, and then a startup like Instagram can happen. This is from Benedict Evans' blog, if ever you look at it. Back in 2013, the big news was mobile is eating the world. Mobile's going to take over. It's growing, it's growing, it's growing, it's going to be huge. There's a lot of evidence coming out now that mobile's beginning to plateau. So really, what's going to be the next big thing? I believe that's going to be 3D. Why? Well, my argument is 2D is actually the abstraction. From cave painting tens of thousands of years ago to diagramming to sharing ideas through symbols, mathematics, words. These have all been necessities for us to essentially broadcast our ideas to other people in order to, inject learning in others and to share our ideas, because there was no other technology available. And when we built the interaction models of computers over the last 30 years, we took those ideas with us. It made the most sense. So, using MS Paint here, in a 2D kind of way, using Windows today, using iOS, Android. These are all sort of 2D interaction models. We are presented with images, we are presented with text, we're presented with buttons. But I think 3D is going to be next. There is a whole huge growth in 3D sensor technology, from LiDAR, which is the thing you see on top of the self-driving cars that scan the world around you, to devices that you can plug into your phones or your tablets to do sort of room or object scale scanning, to displays that can show you 3D and allow you to interact with it. All of these technologies are emerging, but they are growing really, really quickly. So what's the benefit? Why is this all worth it? Well, think about it like this. Right now, the world is full of complex systems. They're very hard to explain, they're hard to understand. And really, if I need to have a dialogue with somebody else, let's say it's my son, and he's asked me, how does a car work? Really, it's the power of my rhetoric. It's the power of how good I am at jumping up onto a whiteboard or drawing something on paper that really kind of gets the message across. I have to suddenly start talking about, okay, so there's the chassis, you take the chassis away, there's an engine, the engine uses petrol, it causes a combustion, et cetera, et cetera, et cetera. It's all of these really difficult concepts, it's a whole bunch of terminology, the barrier to entry is very high. However, if I can show you a car, if I can maybe draw a car or show it to you in 3D using mixed reality or virtual reality if we're in a virtual world, and I can just basically start the simulation. I can peel back the layers of the chassis. I can start the engine. I can superimpose on top the liquid as it moves through, the pistons as they move through. Then the terminology isn't required. My ability to explain isn't required. And crucially, because it's software running, it's interactive. It means that you can play with the levers and dials, you can experiment, and that aids learning. Think about a more domestic setting. Often we want to redecorate our houses. Maybe it's a project for school. Right now, you kind of have to use your mind's eye to imagine, what's the carpet going to look like? What's the wall going to look like this color? It looks awful, that color. We should change it. Well, now we can visualize that just as fast as we're scrolling through Pinterest or a website. But that's just the starting point. Where do we go from here? Well, if we have these sensors constantly scanning the world around us, HoloLens knows what's in my room, and I can walk out of the room and I can come back and it still remembers everything. Well, if we're scanning that sort of information all the time, surely I should be able to ask, where's my keys? And it should be able to direct me, just like a video game with a waypoint. And finally, I want to talk about sort of collaborative, creative work. Many times we want to change the way our office is laid out, or we're doing a big project to redesign a workspace or something else. And what tends to happen is somebody draws up a whole bunch of different plans. Maybe there's some visualization done in a 3D package like Blender or something. There is then a whole bunch of meetings that take place where the designers walk you through everything and they go, okay, well, we're going to put this thing here, we're going to put this thing over here, we're going to do this thing here. Everyone's going, okay, I think I kind of understand what you mean. And then there's another meeting and you kind of redefine on details. And it takes actually a huge amount of time and effort, and often a lot of the time they have to be done with conference calling and other technologies. However, if we do it in 3D, if we do it in real time, I can do a whole bunch of work. I can invite a different bunch of people to a meeting. We can go to that place, or we can see it in a space around us, and I can walk you through it and showing you everything. And in real time, you can make edits, you can change colors, and you can say, actually, we want this thing here, let's move this, let's put this here. And of course, people can be together in the same space or remote. And because we're taking advantage of natural language interaction with avatars or people in a real space, there's none of this kind of awkward conference calling, people jumping in. It's just a very natural, very straightforward, and it's super accessible. Anybody can do it. Everybody will understand it, even my mum. And that's the goal, really. It's about making it accessible to everybody. So how does this tie back into the original story? So really, we're building the foundations, all of the different pieces that fit together that will enable this 3D computing future. We're kind of at like the hello world stage. So what I want to know is, what's going to be that billion-dollar business that's built on top of the platforms that we're building today? Thank you.